Phenol is a pretty caustic material. Believe it or not, it will give you blisters. We had some students once that leaned in a drop of it, and I had 3 students that right in a row got blisters from this. So at high concentration it's dangerous, but at low concentration, like less than 1%, it's chloroseptic throat spray. You know that stuff that makes your throat numb when you have a sore throat? It's phenol. So in high concentration it's really nasty. In low concentration, oh yeah, it's a little spray here and there. It's kind of weird how concentration matters so much. The other one is formaldehyde. This is the same stuff that they used to pickle frogs in for biology class. They don't do that so much anymore because it's a carcinogen, and so try to avoid that. Once it's polymerized, it's safe because it's no longer formaldehyde. You've used that reactivity, but any residual formaldehyde would be dangerous. So those 2 things are in here: 5 milliliters of 90% phenol, 5 milliliters of 37% formaldehyde in water called formalin. We're going to add some acetic acid. This is concentrated acetic acid. Vinegar is 5% acetic acid. This is 100% acetic acid. This acts as a catalyst. It's going to make it happen pretty quickly. But acetic acid is a weak acid. So add a little bit of heat here. By itself, it's not enough to get the reaction going. So we're going to add some strong acid as well. So this situation here is still relatively stable. Yeah, feel free to kind of crowd in here so you can see the beaker. But acetic acid only deprotonates about a couple percentage of the time, and so out of that, what I added, only about 1 out of every 100 is actually acting like an acid. So by adding some hydrochloric acid, we're going to kind of force it to be acidic, and then it's all going to cascade. The temperature is going to rise very quickly, and it's going to polymerize. So keep your eyes open. It's going to happen quick. It's an exothermic reaction because you're making new bonds, and that makes it release a lot of heat. And so it's going to be a pretty exothermic reaction. So it takes about 70 drops of this, but just watch carefully. Soon it will start turning red, and then it will start reacting. I think it's beginning its trek here. Watch carefully. A little more explosive than it was last time. We have some escape down here. But see, that doesn't take a week in an oven. You see it takes about 1 second to actually react once it gets going. But makes that pink solid, and that is Bakelite. This is done more violently than they would do in a industrial setting. You don't really want to have settings like this that just spontaneously blow up like that. But anyway, that's Bakelite, going very quickly from monomer to then solid polymer. So I'm going to rinse this off, and then after it's soaked a little bit, that acetic acid gets soaked out, and then you can do your observations on it. So, any questions on that? No? All right. Well.